Hello, Peggy, Hope, and Sharif. Hope you can hear me.
Yes, my good evening, ma. We can hear you.
Okay, good evening. You're welcome. Okay. Well, without wasting time, because I even wasted a little time and all that. So, today I want us to end mode 1 so that next week we'll enter mode 2. So with that, we will be treating the last 2 units of that module, which is unit 6 and unit 7. Unit 6 is on electron affinity, while unit 7 is on electronegativity. Last week, we studied ionization energy, and we said that ionization energy is the energy required to remove an electron from the valence shell, that's to remove the valence electron from a gaseous atom in its ground state. So it means it has to do with removal of electron. It has to do with electropositivity, those elements that are electropositive, and I told you those elements that will always lose electron, the ones in group 1 and group 2. So those are the ones that ionization energy applies to and all that. And we looked at factors that affect ionization energy. After that, we looked at the periodic trends. That's how ionization energy varies across the period, that's down the group and across the period. Today, we're going to look at electron affinity. Electron affinity is the opposite of ionization energy because it has to do with the energy released or absorbed when an atom accepts electron. So with that, I would begin to share my PowerPoint. So I believe you can see the PowerPoint. Hello? I hope you can see the PowerPoint.
Yes, we can see it.
All right, okay. So I've just given us an idea. So this is unit 6 electron affinity. So I've already explained, but I'll just read what is in the PowerPoint. So electron affinity of an atom is a measure of its ability to accept an electron to form an anion. Like I said, that all those elements on the periodic table, once their shells are not filled up with electrons, they're unstable. So they will begin to undergo reactions. And those reactions will either lead to loss of electron, and when an electron is lost, energy is involved. That's ionization energy. Or the atom can gain electron. That now brings us to the opposite of this ionization energy, as I said, which is electron affinity. So it has to do with those elements that can accept the electron, like the halogen, that's the group 17 element, the group 16, the group 15, and all that. So these ones are the ones that this electron affinity applies to. So we said the electron affinity of an atom is a measure of its ability to accept the electron to form an anion, because once any atom accepts the electron or gains the electron, it will form an anion to become negatively charged. I said it is defined as the energy released or absorbed when an electron is added to the gaseous atom in its ground state, or an energy released when an extra electron is added to a neutral gaseous atom. So if you look at this definition, you just see that it is the opposite of ionization energy. And we represent it by this equation. The element we present as S. It can be any of the element in its gaseous state. That's why you have a G. The energy released or absorbed, that's why you see plus E, to form an anion. So this atom X forms an ion. That's why you're seeing X minus. It now forms an anion carrying a negative charge, plus the electron, this E subscript A, that's the symbol for electron affinity. So that electron affinity is now it's an energy. So it's just showing the energy that has been released or absorbed in formation of this ion that's in this atom gaining electron. We want to look at the factors that, okay, I said, now, you know that when an energy is released, that's an exothermic reaction. Then when energy is absorbed, that becomes an endothermic reaction. We want to look at the factors affecting electron affinity. What you have to do always, once you know the definition of something, you can be able on your own to know what factors that can affect that particular topic or phenomenon we're talking about. What we have looked at before, we looked at atomic radius, we looked at nuclear charge, then electronic configuration. The factor that can affect the electron affinity of any atom of an element of the periodic table is atomic radius, effective nuclear charge, electronic configuration. Remember, the atomic radius is the size of the atom and all that. We want to look at how will the atomic radius affects electron affinity. Now, one thing you have to know first is that, and I've been teaching you this, that the nucleus, of course, is positively charged. The electron is negatively charged. And that the electron is held in place in its orbital, in the shell, by the attraction of the nucleus, the positive charge of the nucleus that attracts the negative charge of the electron. And there's this electrostatic force holding them together. That is why before you can remove the electron, you have to break that electrostatic force, which is, and when you do that, energy will be involved. That involves ionization energy. So once you know that the electron is held by the nucleus, it means any electron that is going to enter again into the valence shell. Because remember again, I told you that every reaction, everything we're talking about happens in the valence shell, which is the outermost shell. So for an electron to enter into the valence shell, and no valence shell can accept more than the number of electrons that is required. That's why when we're doing electronic configuration, I try to teach you all those shells, the maximum number of electrons they can take, which I even gave you a formula to calculate 2n raised to power 2. So that for each of n, show you a particular shell. So by the time you work out that, you know the maximum number of electrons you can take. And when you distribute it, you'll not be able to know the valence, the number of electrons in the valence shell. So once that number in the valence shell has been attained, no electron can enter again. And until that is attained, it will either accept electron, lose electron, or share electron. So going back to what we're saying, remember, who is making that noise? Come, Musa. Can you just... I'll remove you because I'm pressing this in to remove you from here. I'll remove you. I'll remove you. Because what I've just pressed is to remove you. So you better mute yourself. Don't just come and be disturbing like that. So, as we continue. Now, remember when I taught you people about periodic trend of atomic radius? We say atomic radius decrease this as you go across the group, across the period. Then when you're coming down the group, it increases. And I explained to you why, so I will not keep on going over that again. Now, for electron affinity, as you go across the period, remember that the electrons are always keeps on adding to the same shell. Unlike when you go across, that I try to show you, you see to enter another shell, distancing the valence electron from the nucleus. Meanwhile, across, it will be entering the same shell. So there's no distance. There's no inner shells before you're seeing the valence electron. But the effective nuclear charge keep on increasing, holding the valence electron tightly. We're able to explain that. So that means the valence electron, the outermost shell, is able to experience a lot of the effective nuclear charge. Remember, the effective nuclear is the actual charge that gets to the valence shell, the electron in the valence shell. So it experiences more of it, so that when you have an incoming electron into that shell, it will be strongly attracted. The nucleus will attract it strongly for it to enter that shell and be held in this shell. And this will involve a large quantity of energy because of the high effective nuclear charge. I'm talking about effective nuclear charge. And that has to do too with atomic radius, because as the atomic radius of the atom is small, it means the nuclear charge gets more to the valence shell. There isn't much distance, no inner electron screening. So that's why it is small across the period and all that. So you have that atomic, as the atomic size of the atom is small, the effective nuclear charge will be more, and then the attraction for the incoming electron, that atom is accepting, will be high. Therefore, ionization, because we are saying that ionization energy is the energy released or absorbed when an atom in its gaseous state accepts electron. So it means, because as this effective nuclear charge is high, because all this thing too has associated with energy. So there's a strong attraction such that you have strong formation, then huge amount of energy is either released or absorbed. Thereby the electron affinity across the period is high. But if you go down the group where the atomic radius is increasing, you see that the valence shell, I showed you very well how using some elements of the periodic table, some group, to show you both the group and the period. So you see down the group where the valence electron is now distancing from the nucleus, such that the effective charge that gets to the nucleus is not much. So once this charge is much, there's less attraction, less positive charge to attract the incoming electron. It's just a small thing, and this has to do with energy. So the energy of that formation of that electron entering into that outermost shell will be small. And this energy we're talking about is no other thing than the electron affinity. So the electron affinity down the group decreases. So when it now, if we want to summarize it in terms of atomic radius, it means that as the atomic radius is small, the nuclear charge will be more on the valence shell, so that the incoming electron to it is strongly attracted, leading to large release of energy or large energy absorbed during the attraction of that electron into the valence shell. But once the atomic size of that atom is large, the nuclear charge will be less on the incoming electron in the valence shell. So the energy that will be released for the attraction between the nucleus and this electron to be held in place will be less, or the energy that will be absorbed will be less. So that is that about atomic radius in terms of size, small or large. Then the nuclear charge, I've explained both of them. Then electronic configuration. Now I've said that every reaction we're talking about in this element is in the valence shell, outermost shell. Any atom that has this valence shell filled up cannot allow any other electron to enter. So it will be stable. So the electron affinity of that kind of, like the noble gases, the group 18 elements, the electronic affinity is 0. Because no electron can enter again, it's completely filled up. Then the ones that have, almost filled up, the ones that are completely filled up, almost filled up, the electron affinity is equally not much, and all that. So that's that about electronic configuration. Once the valence shell has enough electron, it will not allow any incoming electrons. So the electron affinity will be 0 or very, very less. So that's that about the factors affecting electron affinity. When we say factors affecting, how will these things make the electron affinity, the value of the electron affinity to be? And that's what we have just explained. So let me just go here to what I wrote here. I said atomic radius. When an electron acts onto any atom, the nucleus of the atom holds it by an electrostatic force of attraction, which depends upon the effective nuclear charge and size of the atom. So that's all that I've explained here and all that, but I'm just allowing this to be in case of those who might want to go back to listen to the recording, so that as they are going through, they can have something to look at. So we equally go to the periodicity in electron affinity. That is just what I've just explained to. Across the period, we know that across the period, atomic size of an atom, of an element, reduces, it decreases, but the nuclear charge increases. So the nuclear charge is much on the incoming electron. So that means across the period, electron affinity is high, it increases. While down the group, atomic radius increases, nuclear charge decrease, as I've already explained. then the nuclear charge is less on the incoming electron to attract it, and for it to now remain in the valence shell or orbiter. So the electron affinity will decrease. So that means down the group of the periodic table, electron affinity decreases. But across the period, it increases, because you know the periodic table is divided into group, the vertical column, then the horizontal column, which is the period. So with that, that brings us to the end of electron affinity. I'll stop sharing this, and now we go to unit 7, which is electronegativity. So this is module 7, electronegativity. Now, all that we have been saying all this while, ionization energy, electron affinity, have to do with formation of ionic bond, where you have loss of electron to form a cation, then gain of electron to form an ion. Then I've told you those elements in the periodic table that will lose electron, group 1, group 2. Then the ones that will accept electron, gain electron to form anions. We're talking about the halogens, group 17. You now have the group 16. Then those other ones that are midway, many of them form covalent bond. Equally, you have those ones that are midway. When they bond with either group 16, like oxygen, or group 17, the halogens, like chlorine, fluorine, bromine, they will equally form covalent bond with them. Now, electronegativity has to do with unequal sharing of electrons between two bonded electrons that are covalently bonded. So we defined electronegativity as the measure of the ability of an atom in a bond to attract electrons to itself. And I say consider this bond between this chlorine, between this carbon and chlorine. Also between the second one, between carbon and oxygen. Then the third one between hydrogen and oxygen. These are all covalent bonds. These atoms are sharing their electron. That's why there's a dash to form this covalent bond. Now, what happens? We are saying electronegativity is the ability of an atom in a bond to attract electron to itself. So these two atoms, carbon and nitrogen, I'm talking about the first one, they are in a bond, covalent bond. But this chlorine has a tendency to draw this electron that they are sharing. This is 2 electrons. This one donated 1. This one donated 1 to form this single covalent bond. Now, this chlorine attracts this electron that they are sharing more to itself. It will not attract it and remove it and take away the electron as per total taking the electron to itself to form a full anion. But as this electron is shared, it attracts it towards itself. That is what we're talking about, electronegativity. Because it has the ability to do this, we say it is more electronegative than carbon. Because electronegativity, you have to understand the ability of an atom to attract electrons to itself. So because it has the ability to attract an electron to itself, as it's in a bond with another atom, we say this chlorine is electronegative. And when you compare it to this carbon, it is more electronegative than the carbon. The same thing, this oxygen too. When oxygen is in a bond with an atom like hydrogen, like this, more of the electrons are attracted to the oxygen atoms. So because this defined electronegativity, we say this oxygen is more electronegative than the carbon atom. Then the same thing, like as you have in water. We normally say that water is polar. Why is it polar? Because it has what we call partial positive charge and partial negative charge. I'm taking this from bonding, say in water. You have another hydrogen atom somewhere here, this side too. So as this oxygen is in a bond with this hydrogen, because oxygen has the tendency to drag, like let me be using the word now, drag this electron more to itself. Then it is electronegative. And when you compare it like on a scale between it and hydrogen, it is more electronegative than hydrogen. And once this atom attracts electron to itself, it will become, the one that attracts the electron to itself, the electronegative one, will become partially negatively charged. It is not fully negatively charged because it did not remove the electron completely to itself. Because it's when it does that, that we now say it's fully, negatively charged. It forms an anion. This one, there's no formation of anion, but it will drag some of these, most of the electron will be shifting more to this side, even when they are bonded together. So this chlorine will acquire what we call a partial negative charge, while the carbon will acquire what we call the partial positive charge. The same thing applies to all these. So that I just use this to explain to you what we mean by electronegativity, the measure of the ability of an atom in a bond to attract an electron to itself. I want to look at periodicity in electronegativity. Normally, the electrons towards the right, not the group 18, which is the noble gases, are excluded from this, but this one, the electrons is completely filled up. So that's why we say they are stable, they are unreactive. But electrons, group 16, group 17, they are the ones that have the tendency to do this. So they are electronegative when you look at the elements in the periodic table. So with that, we have come to the end of this module 1, which we treated the 2 last topics there, which are unit 6, electron affinity, and unit 7, electronegativity. So if you have any questions, you can ask. I don't want us to treat more than this so that you can assimilate the one we have done and be able to marry them with all the things we have been learning, because that's why in your course, the way this syllabus or curriculum is done is from simple to going up complex. So it began with the one trying to help you to understand about their things called atoms and elements and their arrangement in the periodic table, those who try to arrange it to what we have now, and for you to know how they are arranged in order of increasing atomic number and all that. Then you now have the group, the period. We now looked at how do you now distribute these electrons, which now took us to electronic configuration and all that. After that, we now went into other things like this ionization energy and all that, because now we've understood the elements of the periodic table, their distribution. Then you have to know their behavior. Which one gains, which one loses. And when it loses, energy is involved in removing that electron that is going to lose. That's ionization energy. Then the one that gains, energy is involved. It's either released or absorbed for it to accept the electron, that's gain that electron, which is what we have looked at, electron affinity. Then when there's formation of covalent bonds, when they have to mutually agree to share their bonds, the electrons, I mean, to form a bond. In some cases, some of them, except those electrons are the same, like carbon to carbon, chlorine to chlorine. Once they are of the same atom, then none will be more electronegative than the other. They will share, no one will drag it or pull it to itself. It will be like that. So there won't be anything like electronegativity there, but it is when you have them different types. One is stronger than the other. So it begins to attract that electron. That's now took us to electronegativity so that you understand these terms, how these elements behave, and these phenomena that are associated with them. So that's that about this. So if there's any question, you can ask before we call it a day.
Hello, ma. Good evening.
Yes. Who is that?
It's Oebuchi Princess, ma.
Okay, ask your question.
Okay, but sorry, I believe some of us came a little bit because our physics took a longer time, and the beginning of this facilitation, I was not present, so there was a formula you talked about. I couldn't pick it up. I don't know if you can.
You have to go and listen to that video for you to.
Okay.
I can't begin to teach that. Everything, every topic we have treated to the last one. That's the one we did last week on ionization energy is there. I've pasted the link. So what you do when you go to the eLearn platform, when you go to the eLearn platform, go to previous recording.
Okay.
Click on previous, just go to facilitation. Then you see below it previous recording. Click on it. It will give you all the link. You see week 1, week 2, week 3, week, I think we are in the, you see, just when you go through it, you will see them all.
Thank you.
Somebody raised, you're welcome. Somebody raised hand. Okay, I think I'll stop sharing this so that when I can now see Michael Agaba.
Yep. Good afternoon, man.
Yeah, good evening.
Good afternoon.
Welcome. Good evening.
Mommy, I love your class so much, but today this man again class with us again, physics. We're just rounding up from physics class.
I told you I will talk to him. I'll talk to him about it. But sincerely speaking,
yeah,
I forgot because of very, very busy with work. By God's grace, I won't forget today. As I end this class, I will call him so that he will know that he will have a next class immediately after this.
Thank you, man.
You're welcome. Any other question? This screen at times makes me, I don't see very well. So let me, I've answered Michael. So I want to believe there's no other question. It means by God's grace, we understand it. And again, you can always, like I said, the recording is there up to the last one we did. And by God's grace too, by the time in the next 1 hour when you give me the link and all that in my mail, I will paste it there for you to see and all that. So we will then meet again next week, Tuesday. If I will be chanced to teach you on Saturday, by Friday, I will let you know. If not, if you don't hear any message from me, it means I am not chanced. Because all that I'm trying to do is to make sure that we finish this, then have time for revision, and then go through some past questions and all that, because I would really like to treat past questions with you to assist you and all that, so that you see how some of the questions too can be. All right, so see you either Saturday if I'm chance, if not next week, Tuesday. In the meanwhile, read your book, read your book, and take good care of yourself. Bye.
Bye, ma. Take care of yourself, ma.
Thank you.
Please, the Friday, will you give us an email to tell us? Is it through an email you
Yeah,
will?
that's what she said.
Yes,
She said
that's what
she'll
I
give us
said.
an email.
All
Yes,
right.
if I'll be chanced on Saturday.
Mommy, what about
and
those?
that Saturday, I know you always like in the evening. Is it not from 7 or 8?
Yeah,
Can't remember.
it's 8 now.
8.
Mommy,
So,
what about people like us that don't receive email from you?
I don't know why you don't get email.
No,
I
they
know
have not
why.
I don't
Some
get email.
of them didn't activate their email. So if you're
What
on
are you
any
saying?
group,
What's
they'll
in
post
it?
it on the group.
So activate your email.
My
Activate your
stuff
email.
is activated, but
It
I'm
is
not
not.
getting.
It's not.
Hold
I
on.
don't know what to do. All I know that I always send email. I send email to all of you. So if you're not getting it, I wouldn't know what the problem is. Maybe why don't you join a particular group, as she's saying, so that if you don't get it, those that got it can
They'll send it on the group.
The chat is always plenty on the group.
I
That's
bet
the
those who
problem.
know how to activate email, I bet this man not activate email.
It's not about. It's not
Like this
about.
Go to your
class now,
study center.
some of us are not
Go to
aware of
your
the
study
class.
center.
Wait.
They will help
I
you.
did that
your
already. I
portal
did that already
and
now.
check
I did that already.
class.
It's not about
already.
activating it. There's
Okay,
an
do you
app.
know what? Can
There's an
somebody
app.
volunteer to tell them how to activate and all that?
They should just tell us the process.
Let me explain something.
Okay, we're listening.
Well,
Yeah. So if you don't have a laptop, it will be harder to activate it. You
we
can
have
activate
laptop.
it with your phone. You can activate it with your phone. If you don't have the app, because according to them, they say Noun affiliate for Google. So there's an app that you have to download that you'll be getting notifications.
If you're
Can you
using
hear
an
me?
Android phone, you can
What's the app?
shift your mail
What is
to
the
your
name
work
of the
mail.
app?
I don't even
What's the name
know
of
the
the
name
app?
of the app, but I
It's
got
not
that
an app.
notification.
Hello.
It's
It's
an
not
app.
an app.
I'm telling
It's
you that
not
it's
an
an
app.
app.
This
It's
one
not an
house.
app.
There's no need for
So
app.
the module app.
module app.
Hello,
I
can
know
I say
about
Thank
something?
you.
module.
I've
Yeah,
been
it's a
to
module
school.
I know
app.
about
Module
module.
app.
Apart from
Hello,
the module app, you can share your
I've
phone. You
been
can
to
use
school, so
your work email for your school mail. So it will be
I've,
easier for you.
me,
Please,
I've
can
tried
I
that,
ask a
but the thing do
question?
not work.
They are
This email
different
we're
though.
talking
You
about.
cannot link the two together.
hello,
I'm
hello.
asking a
This
question.
thing,
This
this
email we're
thing.
talking about. Wait,
Hello.
first now. This email we're talking about, is it the one that is that is actually composed with NOM email? I'll be our personal email that we provided in school.
Oh,
Please,
it
which
is
of the email is that?
No,
Use
it's a
their
now
NOM
Email.
email
now
with
it's
your
a
Now
matriculation
email.
I've been trying to
number.
activate that
Listen,
and it's not working. It's not working.
it's a now
listen,
email,
bros,
but
Okay,
you
listen.
can
see.
log
Not
in
First
with
of
working.
your
Go
all,
phone.
you
to the
need to
school.
go
They
to
will
school.
Hello.
verify it.
You need to go
Excuse
to
me.
school so
Somebody
that they
just
can.
said he can drop I think what he said, he can drop or tell you how you can do it. So please, can you put it in the chat box how they can,
Yes, ma'am.
activate
That'll be
this
Let
fine.
thing?
him put the
That'll be fine.
process on the chat box so we can be able to get across
Okay,
to
just
it.
do that. Give me a minute.
But the easiest way is to go to your study center.
Yeah,
That's where
just
I'm
go to
already.
the
Oh,
Exactly,
drop
center.
it, drop
exactly.
it, drop
The
it.
thing is,
We are
not
going to
everybody
try
can
to
go to their study center. That's the
That is
thing.
it. That is it. Drop it. Let's
But
see.
if they,
Yes, you
if
can go
they
to your
school,
study center, but not
wait
everybody
now.
can go.
We do not need to go to study center to register
If
our
You can do
someone
email.
know
it
how
by
to do
If
it,
you want to
yourself.
yeah, you
register
can
your
help us
email,
by doing that now.
Hello,
If you want to
Nobody
register
will
your
help you.
email,
Nobody will help you to do it. You will have to go
yes,
to school until they activate it in school before you can be able to do it on
Yes, they
yourself.
must activate
If
it
they did
in
not
school.
activate it
Yeah.
in school, I went to school myself. My wife and I, we went to school. Even when I submitted my wife phone, they did not do it. They said they want to see my wife before they can do it.
Baba,
So they have to
Baba,
activate it in
Baba,
school.
hello,
See, what group are you
Activate
in?
it in.
Sir,
hello.
please, what group are you in?
I activated mine myself.
Baba, wait.
Let that guy
The
talk.
question, let us understand the
Let that
question
guy
first.
talk.
Someone
Let that
that
guy
have
talk.
experience
I
to
beg.
talk. So
Who
speaking
wants
from
to
Let us
talk
experience,
now?
understand the
allow him to
question
teach us,
first now.
please.
Let us
Okay,
understand the
when you
question
log
first.
in, to your data page, you will see
Yes, sir.
an email that now have already created for you. But if
Yes,
they have
yes,
not
sir.
Yes, we have that.
activated if they have not activated you cannot make use of it. You
Okay.
understand me? Once it has
That's
been
the activation we are talking about.
Your matric
wait,
number.
now,
Your
your
matric
matric
number is your
number, your
mail.
matric
Your
number.
matric number is your mail.
It's
With
your
matric
mail.
Which I
number.
saw
Your
it.
When you were doing your registration at first, the email
hello.
was given to
Hello,
everybody.
hello,
The moment
wait
you
Can
were
I say
doing your
something?
registration.
hello, wait
If
now.
your email is activated and you want to log in it on your phone, it is your email you will make use of, and your matric number is your
The
password
matric
that you use to
number
log in.
in NOU in small letter.
The issue is the school email is not activated, and we're asking how do we
Hold on,
activate
hold
it on
on.
our phone?
Sir,
That
Activate
is
it
please,
with
that
when
is
phone
did
to
what I
you
am
activate
when
your
did
email.
saying.
you sign in for your
It's
email?
done.
Because after one day the email is supposed to have automatically
That
activated.
working.
So what you're supposed to
See,
do,
Yeah.
you're supposed
hello,
to put that
hello.
email
If you have
into
your
your
matric
own
number
Gmail.
already,
I
if you have your
went
Okay.
matric number already, if
Once
you
you
have your
put it in
matric
your Gmail,
number,
what next will you do?
let me talk
Continue.
now. If you
You
have
put
your
it in
matric
Gmail,
number
what next will
already,
we do? Continue.
hello,
That's
if
all.
you have your hello, if you
You
have
just
your
need
matric
to
number
activate
already,
it on your own
activate
Gmail.
it on your home Gmail.
One house now. Let's take
if you
one after. God.
Wait,
hello,
hold on. Sir,
yeah,
please, what group are you in? Because it won't
I
be
mean,
easy for us to communicate on this platform
I
as it
just
is
I
now.
just
What
joined the
group are you
It's
in?
I
Faculty
just
of
jo-
Science.
I just joined
Yeah.
the chemistry group now. I know I just saw the link and join it right now. Yeah.
Okay.
Guys, see
Now,
what you will do. Just go to your Gmail. Look for add
Okay.
another email. Look for add another email. Click on add
Okay.
another
Okay. Go
email.
on.
So it will just open a
Okay.
space for you. Then add that your matric number, that Gmail that now I've created for
Okay.
you. Just add it to it.
Okay.
Then click on next. So once you say
Okay.
click on next, you just add your password. If they have activated it in school, automatically it will change to your work.
So which of the
can
password
you,
will I
sir,
enter?
please, can you
The
share your
password I normally
screen?
use to log in
Sir,
with
please, is
my
it
portal.
possible for you to share your screen?
Yes.
The same password that I use to log into my portal, right?
I'm coming. Let me screenshot something. I don't know if I can.
No, don't screenshot. Like share it through Zoom. You see on your this thing, they'll show share. You click
Okay,
on
let
screen.
me check.
That'll be better.
So which of the password are we entering?
Is your
Your
matric number?
password is
Your
now
matric number, when you log into your data page, you see
in
that
small
matric number
letter.
down there in small letter where you put it.
Okay.
So just
Your matric number
just
is
copy it.
small letter.
You
Okay.
copy it. So when you copy it, you go to your Gmail. They will now say click
Okay.
on add Gmail. You want to add another Gmail because like me, I'm
Okay.
using like about 3 Gmail. So the
Okay.
now own is the third one. So you just click on add Gmail. Then once you click on add Gmail, they will give you a space where you add your Gmail. Then just paste
Okay.
that now mail that you created. When you paste it,
Okay.
click on next. When you click on
Okay.
next, if they have
Okay.
activated it from school, the next thing they will ask you put your password.
So which password am I going to put? Which password?
That it might be the
Create
same
your
that password. It's the same that password. You might
I'm
use
using
that
to
the
log
same
into
password.
my portal.
Yes,
hello,
exactly.
Yeah.
Before
That's what I'm asking.
create your own email.
before you
Baba,
change
that
it
thing,
again.
that thing did not
Someone
need
is
activation
saying I
from
tried
school.
doing it
I've
and
That thing did
already
not need
changed my
activation
saying
password
from
can't
before
school.
find
now.
your
I
mail.
have
Baba,
changed my password
that
before
thing did
now.
not
Can that same password
hello,
work?
hello, that thing did not need activation from school. That thing did not
In
need
the
activation
chat,
from
someone is
school.
saying I tried doing it
If
and
you have your
I
matric
saying
number,
I couldn't
just go
find
to
the mail
wait.
something.
If
Your Gmail.
you have your
That
matric
one
number
is
already,
too
if you have your matric number, if you have your matric
One
number
house now.
already,
One house.
Okay.
if you have your matric
Let's
See, the
talk
number
one
people.
after the
already,
other.
hello,
One
if you have
house.
your matric number already, if you have your matric number already, just use NOU and your matric number at
It's supposed to be in capital
now.edu.ng.
letter.
NOU, your matric number at
In capital letter.
now.edu.ng. Then you go down and you input your matric number, NOU, your number as the password. Then again, it will ask you to send your password. That's all. There's nothing added. I think I've sent
Okay,
the screenshot.
what about those that have changed their password before now? I've changed my password already before. So will I enter the one I changed? That's the question.
You send your password. That's for your portal now. That's for your portal.
That's my portal, yes. Yes,
No,
yes.
this one is for email. This one is for email. This one
Do
is for email
you know I've tried
entirely.
the same method for the email? It did not accept it. I've tried the same thing. It's telling me wrong
Baba,
password.
say you fit drop your this thing, make them help you do and make them send them back to you. You can just change your password yourself.
All right, thank you very much. Thank you. I will
You can
still
just
follow up on the
message.
group chat. Let's see
You
what
can just I screenshotted it. So you can just message that number. I'll just push up.
Okay, have you seen my number?
No, I screenshotted how to activate it on the WhatsApp group. So just message me through that number.
Which of the WhatsApp? Where is the number?
Chemistry 101. I screenshotted the group. I screenshotted
Okay,
the
I've joined it already. I've joined the group already.
Have you seen the
I can
screenshot?
it now. I can't see the screenshot.
Come, let me send it again.
Babe, send it again.
I'll send it again. I've sent it. So just message that number.
All right. Okay. Hello. Hello. I've given you enough time to try to. Hello.
Thank you very much, ma. Really appreciate, ma. We are here. We're here, ma. We can hear you.
So I'm giving you enough time so that your classmates can put you through. I believe they put you through. And again, they've asked you. They've joined. I think they've given you the link to join your WhatsApp group. So you join them so that every assistance you need, because that's the essence of that group, people can help one another and all that. So, all right. But before that, somebody raised hand, Lasisi. I don't know if he's still here. So, Lasisi, if you're still here, you can raise your hand maybe to ask a question, so you can do that. Or if it's not here, then we call it. All right. So, we end the class now. Then we'll see as discussed. Bye.
Bye. Thank you,
Bye,
ma'am.
ma. Thank you, ma.
Welcome.
Thank you, ma.